Hello everyone. My name is Raghav Sharma and today I'm going to talk about blockchain technology and its application. As part of my ongoing research, I'm making this presentation video for my course research methods. Um, so basically research methods, which is a CS605. So basically my research is guided by a PowerPoint slide that I have beside me, side by side. I wanted to keep it at the back so that it's visible, but because the screen is laterally inverted when I recorded from my other laptop, so I couldn't do it. So I'm submitting it as a separate presentation on the Dropbox. So blockchain technology, well, it has really been a buzzword, isn't it? We've heard about Bitcoin the most than any other any other technology. It's become the seventh largest currency in the world. So the blockchain technology, which was first application, which the first application, which was in the Bitcoin, is really a technology that is going to revolutionize how we do things in not only in the field of electronic payment or transaction system, but also in various other diverse areas like smart contracts, decentralized organizations, decentralized autonomous organizations. Also, it can be useful in the field of healthcare and many more. So today I'm going to talk all about it. Basically, my presentation would focus more on the application side than the architecture side. But I would basically touch on the architecture side and what blockchain really is before diving into the applications. I'll give an example of Bitcoin, as in how it works. It was first proposed by a group of anonymous group of people termed as Satoshi Nakamoto. So Satoshi Nakamoto, they basically published a paper and presented with in 2008 they first released Bitcoin, and they presented a paper on how the overall architecture is going to work. And even though there were other different technologies which had similar architecture already out there, Bitcoin was the first ever implementation of blockchain technology. And so we're going to talk all about it in my presentation. So my presentation is basically structured like this. I'd first talk about introducing what blockchain really is, the types of blockchain technologies out there, the various different the details about its architecture, how it works, how the blocks are formed, how the consensus happens, how the proof of work happens, proof of stake happens, and how they're verified and the transaction is then added to the chain. I'll talk all about it first, and then we would dive into my analysis on how this could be applied in different areas. I would also talk about in the architecture section. I'll also talk about distributed ledger, which is basically a new type of database architecture that is going to decentralize everything we do, decentralizing institutions, decentralizing the economic activity, and a whole bunch of other things. It's applicable in so many different areas. And so I'll talk about the distributed ledger. I'll talk about consensus algorithm, how the algorithm works to develop consensus amongst different nodes after the proof of work is done. Proof of work basically validates. Proof of work basically is a mathematical puzzle that is solved by using certain computation power. So I'm going to talk about all about it. So it is basically done by miners, and I would also talk about again, proof of work, proof of authentication, and everything. Nowadays, like I also mentioned earlier, I would talk about Bitcoin, and by giving it as by giving an example, because it's the first ever implemented cryptocurrency, and it uses blockchain technology. We know all about it, and all the nuances associated with it, its benefits. And I would also as included in my slide, I would also talk about as included in my slide, I have this screenshot of the live blocks of chain that could be seen in bitcoin.org, bitcoin.org, and how the real-time transactions happen. If you go side by side with the slide, you can basically see the screenshots of transactions in real time, the confirmed transactions and unconfirmed transaction, and I'll talk a little bit about it, and I'll talk about why the research is relevant, like what's the and also I'll talk about what's the motivation behind me choosing this topic as my research topic. Not only is it interesting, but it is a technology that has so many applications, so many different applications, and I would talk about both relevance and motivation, and more on motivation, and then the other remaining part of the presentation would be focused on application, more applications of blockchain technology, and the future growth, what it can become, the potential, given the potential this new architecture has. And also I would give my overall assessment after reading number of research papers that focus more on application of blockchain technology in Internet of Things, as we're transitioning into a world of interconnected devices. A secure cryptographic model like that blockchain technology offers is always going to be useful, because not only is it foolproof, is it tamper proof, it is also very distributed, and it is also very easy to access, and because it's decentralized, it's fast, and this is exactly the kind of model that's required, not only in dealing with huge amounts of data in healthcare sector, in economy, in banking transactions that we do, but also in many other fields. And I would give my overall assessment more sort of like a overview, or a overall assessment, and then I would conclude with the conclusion by giving a brief idea about the things I've learned, I've discovered, and many more. So let's dive into the presentation now. I cannot stress more on the importance blockchain technology has, and the different ways it can be applied, the different ways of application it has in different areas. And even though it might sound like a cliche, but I would have to go through certain introduction and architecture, and because it's really important. I cannot stress more on its really unique and simplified architecture. So let's dive into the introduction. What blockchain technology really is. So block and chain. It's easier to picture in our mind. Blockchain technology is a technology that consists of blocks of information that form a distributed ledger, that form a chain. It is highly scalable. It is highly decentralized, and it basically is a peer-to-peer network technology that consists of architecture which, like I already explained, works like blocks of chain. It consists of publicly available distributed ledger that consists of blocks that are only added to the chain after a process called consensus. Now I'd come back to the describing what consensus is. Now, to ensure that only legitimate transactions are recorded into blockchain, the network confirms that new transactions are valid and they do not invalidate former transactions. A new block of data will only be added after consensus is reached and the validity of the transaction is confirmed. So consensus is achieved by two different ways. First, the initial model used something called proof of work, and these days there's another consensus mechanism which is called proof of stake. I'll come back to that later. So there are basically three types of blockchain: public, private, and hybrid. Now, public blockchains are public and they're readily available to public users. They're decentralized public ledgers that anyone can go and look back at. So after these transactions are valid and added to the block, added to the chain, so each of the anyone can go and take a look at the transactions that have happened. So you see how the process if we consider a electronic payment system or any payment system. So from the point of view of economic model, payment system, decentralizing basically would mean if I have to buy something, I would not have to depend on a bank or a centralized institution where I would have my money. I would use my card. So there is no transaction fees in the case of blockchain technology, and the database is not stored centrally. So if something happens to the database, in the case of our traditional model, there's no fear of losing the data. And so private blockchains are basically they basically use the same principle of the public system, but they're made in-house by a company. For example, if Wells Fargo wants to have a model of transaction, a cryptocurrency that is efficient, that reduces friction, that provides fast access to users, they develop a in-house currency that only works within the bank's system, cryptocurrency, then that would be available to only the customers who are registered with the private bank, let's say. Then that is a private blockchain. Now, hybrid is the technology that uses the concept of both the technologies to make a system. For example, Facebook is looking forward to release its own cryptocurrency. So I think by the end of 2020, they're looking forward to release their own cryptocurrency. So that would be something that we can term as a hybrid blockchain, because it is readily available to public. Plus, it also uses the technologies that are basically involved in private blockchain. Now, blockchain technology has basically been described as email technology. Like email, you can see how in the 90s, when ever since email has been discovered, it is still being used. It's because of the efficiency, because of the security that email offers. It is still being used, and I see it still being used in many years to come. And blockchain technology is also seen like something like an email or internet, which has only grown ever since the first application of blockchain technology was released in the market in the form of Bitcoin. Now, one of the most important thing about blockchain technology that has helped it to be famous and to be renowned in the world of cryptography, and in the is because of immutability, because it's foolproof. Describing, in other words, its resistance to tampering. It has basically helped us create a system that has no duplicacy at all, and it's tamper proof. So from the cybersecurity point of view, it's foolproof, and it has because it follows a very secure cryptographic model. It has inspired the technology has inspired many other areas which have used its concepts for implementation, and that is one of the reason. The immutability is part of the reason why the technology has gained so much value, and it is being used in the world of cryptocurrency, because a money, when you talk about cryptocurrency, you're basically talking about payment in some certain value. So if I have a paper note, someone might forge the note and duplicate the note by printing it. So until it reaches the central bank, and when it is flagged and traced, these modern days, the banknotes have India has recently launched a banknote which is much more advanced, so it's easier to distinguish it from a duplicate one. But many other economies follow a model that has a very inefficient system to keep track of all the forged banknotes and the real notes. So until it reaches the agency that kind of takes care of all these standards and checks these notes, it just cannot be taken out of the market. And with cryptocurrency being but in case of cryptocurrency, because the technology is foolproof, it's resistant to tampering and duplicacy. Its relevance in the world of cryptocurrency is increasing day upon day with newer cryptocurrencies like Ethereum, Litecoin, Ethereum Classic being released and successfully growing in the market. Now, blockchain does not only have its application in the field of cryptocurrency. There are many other fields like healthcare, database, handling big data. The data that has a massive amount of velocity, variety, and variance, that comes in all different formats. And this technology has inspired, has produced a model that is efficient and that's easy for all these different devices that are connected to our internet to be handled in a manner that's secure. Not only that, it also has many different promises in the field of legal sector, with concept like smart contracts being used more and more in everyday life, and also in the field of cybersecurity, because it's from the cybersecurity point of view, the cryptography it uses is very foolproof. Now, I want to read something from the PowerPoint slide that I mentioned. After reading a Harvard Business Review article that talks about blockchain, it quotes, "Blockchain could dramatically reduce the cost of transactions and, if adopted widely, reshape the economy." Blockchain really has the ability to reshape the economy, change how we deal with things. So now I want to move on to distributed ledger, which is part of the architecture of the blockchain technology. So distributed ledger is a database which is controlled by large number of participants and always remain available. Unlike the traditional model where the database is centrally located, it is controlled by a central institution or a organization, and in order for data to be processed, it has to be there has to be data mining, data cleansing, and so many things that had to be done. But in this case, everything is controlled by the nodes, and a data is readily available to everyone, and the data can be fetched and stored using a model that's foolproof. So it brings about a massive amount of transparency into play. So the nodes are full-fledged and passive participants in the distributed database. The updating of the database is done by validating the full nodes, and reconciliation is achieved by using a method called consensus. Now, to address the current problem of general banking procedure, the blockchain we think could provide a solution by preserving confidentiality, integrity, and availability of the data. Typically, a blockchain can be defined as the chain of blocks connected in series, and because and in a database, each blocks consist of customer data that generally consist of different demographic details, transaction history, the preference of the customers, their address, account balance, and the contact details. So when all this block is connected with respect to the customer, it gives this new architecture makes sure that the information is foolproof before the transaction before the nodes reach consensus and the transaction is verified and validated. Now, I want to talk about consensus algorithm, what it really is. Now, the consensus algorithm consists of two variety of blocks, namely validation and authentication. The taxonomy of validation of blocks consists of proof of work and proof of relevance, while the authentication of the block consists of proof of authentication and its branch. Now, I want to dive into proof of work. Now, what proof of work really is? Proof of work is the original consensus algorithm in blockchain technology, which is also known as mining process. In this, what happens is, like, all the transactions are time-stamped, and a distributed timestamp server needs to be implemented on a peer-to-peer network to confirm the transaction process and produce new blocks in the chain, which is basically what we call as proof of work. Now, in this technology, a transaction is verified, and a complex mathematical problem that is associated with the block that is being created is verified by miner. A miner needs to find the nonce which satisfies the condition. For computation, miners search for specific nonce which gives the desired hash value, and in every block there's a hash value which is a combination of the previous block plus the previous block's final hash plus the nonce and the hash value of a transaction data. So that's how the hash value combination of hash value is created. So a nonce starts with 0, and when a required hash is obtained, it is incremented every time. So once a nonce is found, a miner can successfully add the block to the blockchain, and the transaction is considered confirmed. So once they're confirmed, they're placed in the block. Now, what's proof of authentication? So proof of authentication is a new consensus algorithm for blockchain, which helps to make blockchain suitable for distributed systems by authenticating the blocks. So the proof of authentication follows conventional blockchain model with block verification. It basically targets to authenticate the blocks that are that follow the same method of a transaction of blockchain. So I want to give an example of Bitcoin and how it has been implemented. Bitcoin, in case of Bitcoin, it basically is the decentralized. It has a decentralized ledger or distributed ledger instead of a centralized one that separates it from any other currency. The ledger basically gets updated every day. Payment is instant. There's no duplication whatsoever. So we can actually see the blocks of Bitcoin live. I've put a screenshot in the PowerPoint slide, which shows us the size of the blocks, the name of miner if they put in they comfortably submitted a name, the transaction number, the age of the block that was created, and the height of the block. And also there are transactions happening all the time. So for Bitcoin, it usually takes like 10 minutes in average for a transaction to be confirmed. So I have a screenshot of transactions that are confirmed in real time, where proof of stake miners solve a computationally intense mathematical problem, and after it is done, they reach consensus, and within those 10 minutes, in case of Bitcoin, a transaction is confirmed. And and after it's confirmed, it's added to the end of the block. Now I have another screenshot of confirmed transactions, which contains transaction hash and the age and amount of which in Bitcoin value is given in which is given in Bitcoin value. The Bitcoin value, Bitcoin basically has a value. It's like a stock traded in the stock market. So currently Bitcoin has a value of 7,000 to 8,000. It goes up and it comes down as to the supply and demand. It's part of a economic model like stocks, and its corresponding value when compared to dollar amount. So that basically confirms that the picture basically explains the confirmed transactions. Now I want to move on to relevance of this research. Why the research is relevant? Because blockchain technology is a decentralized technology which was introduced in 2008 by a group of anonymous people called Satoshi Nakamoto in their paper. Blockchain technology, because it has established itself as the core technology that can drive innovation in multiple fields, its application is really the list of its application is really long, and which is why I've taken this technology as part of technology as part of my research, as my main focus of the research. Now the main motivation behind this application, this technology, me being choosing this technology, is because blockchain technology has established itself as the core technology to drive innovation in multiple fields. The research basically focuses on nuances associated with applications of its application in various fields, its applicability to solve various problems in that exist in current technologies, and the need for a more transparent model for information sharing, a transparent model in case of economy, a transparent model, a decentralized model, a fast and efficient place where a model where there's fast and efficient access to information, and a model that has easy sharing of information and data, easy way to validate information or any data. That can reduce duplicacy and redundancy. Also, there are other motivations because it has because it brings both the worlds of cryptocurrency and parallel processing in a peer-to-peer network together. It sounded fascinating, and there has been more researches that are focused on this technology, and the collaboration with various other multidimensional technologies, which has reduced friction as well as delay and redundancy in various financial transactions. The research basically was guided by questions that helped me analyze various multidimensional approaches to studying various nuances and applicability of blockchain technology. The research basically was focused more on figuring out the current stages of implementation of the model, and where we are currently in the application in various fields like database, cryptocurrencies, currency, and the applications that are possible and still being implemented, like smart contracts, and the possibility is completely decentralized autonomous organizations. So all these different new technologies, these terms, these buzzwords have led to me being choosing this topic as the topic of my research. Now I want to dive into more applications. There are various applications of blockchain technology. I already explained a lot of them, but I want to go through some of them again. The first application could be digital currency. The other could be smart contract. A smart contract is clearly defined contract in terms of computer codes that users can just read and sign digitally, and which would use the blockchain technology as its core as its core architecture, which would replace all these intermediaries in terms of one organization coming to consensus with another organization for certain tasks or for certain goods and services. So smart contract would change the way we do contracts. So it's another application. The other application is decentralized autonomous organizations or decentralized organizations. So decentralized autonomous organizations are basically they're organizations because we would have self-executing smart contracts. Organizations would not have to depend on individuals who are struggling in between, or let me put it this way: the legal system that we have, which predominantly is focused on the struggle between individual, the state, the market, and it's seeking to harmonize computing power dynamics and trying to find the appropriate balance between interests of the public sphere and it's eager to preserve public order and national security and interests of private sector. This technology brings in a possibility of a organization that does not have to depend on lawyers or various lobbyists in order for one organization to deal with another organization. So we already have the smart contracts, multiple smart contracts that can be bound together to form a decentralized organization that operate according to the specified rules and procedures that are defined in the contract itself, which would basically be in the form of code. So it would transform, it would basically end up transforming Michael Henson and Mackling's theories that entities are nothing more than a collection of contracts and relationships into reality. So it would change the social implications of how we do business, and it would replace a traditional organization where decision making is concentrated more on the top, and the process of it would basically decentralize the overall organization. Now another application is decentralization of economy. So like I already said, because in order to do transactions, we would not have to depend on a central agency or bank or central government. Cryptocurrencies would highly decentralize the way we use money and the way economy works. In a system regulated by self-enforcing smart contracts and other technical arrangements, there's less of a need for judicial enforcement, because the way in which the rules have been defined, the code, the same mechanism by which the code is the same mechanism by which they're enforced. So over time, The judicial system would also be affected. Like law and codes may merge, and thereby the only way for people to infringe the law is to effectively break the code. So if there are already defined nuances, the things that we can do, the things that we cannot do, properly defined in terms of code or law, we would not have to depend on lawyers, because it's basically if the blockchain model is applied in the field of law, and that would bring in more diverse problems and solutions and different way of thinking, and it would be difficult, because given the current system, how it's working, it will be very difficult. But that's something that can be another application. Now the other application would be decentralized government. So the way government works is a central government enforces some policies, and the ones in the lower tiers follow the policies, and so on. So it would also change the way a government is run, and so on. Also, it changes it has a massive application in terms of database and how data is handled, and also in the field of Internet of Things, and being used with AI. It can be used in autonomous robotaxis, like Tesla, which is planning to make the cars completely autonomous and release robotaxis. The cryptocurrency or a blockchain technology can be used to communicate for communication of these different cars, so that there's no duplicacy. So if someone orders a car like Uber, a autonomous car, if it is at the doorstep, it will automatically, using the technology, it'll automatically verify that other person is not using the same or is not making the order of the same taxi, so thereby bringing a automatic balance. So that's another application that blockchain technology can have. Now, going on to future growth, there's so many areas that can help us. There's so many areas where this technology can grow, like digital identification service, algorithmic governance, legal sector, rise of Lex Cryptographia, which basically means is associated with law and cryptography being used in the law, or rules administered through self-executing smart contracts and decentralized autonomous organization. And also Internet of Things. It has a massive growth possibility in Internet of Things, detecting fake news, fake information, and authenticating validity of information, and implementation of blockchain for privacy. How blockchain technologies can advance in the leasing sector, how leases are done, how purchases are made, how sale transactions in commercial real estates are done. So it will also change the real estate sector. So blockchain is a technology with tremendous promise, and it has application into various digital identification service. So it can also so we would also have identification cards in that would use the same platform, so that there's no cases, there would be zero cases of duplicacy or identity theft or identity fraud. So this platform basically enables It basically combines a blockchain repurposed as an access control moderator with an off blockchain storage solution. Users are not required to trust any third party and are always aware of the data that is being controlled about them and how it is used. So users have more access. So this would also bring various implications in terms of privacy. So we're moving into a world where people are really they're really critical and vocal in regarding their privacy, and they're sensitive to towards their information. And if blockchain technology is applied for the identification service and for storing private information, it's going to be much more foolproof and much more efficient. So the blockchain, in this case, what happens is the blockchain recognizes the users as the owners of their personal data, and companies in turn can focus on utilizing data without being overly concerned about property security and compartmentalizing them. So we see how Apple and Microsoft and Facebook are spending tremendous amounts of money to provide their customers with a proper model that guarantees their privacy. A blockchain technology being implemented for this use can basically bring the problem of identity theft and duplicacy, and can secure our private information in a much better way. So also with a decentralized platform, making legal and regulatory decisions about collecting, storing, and sharing sensitive data should be simpler. So moreover, law and regulations would be programmed into the blockchain itself, so that they can be enforced automatically. Now moving on to my overall assessment after coming on to this part of the presentation. So blockchain technology would basically trigger emergence of Lex Cryptographia, which I already described as the legal practice that uses smart contract, does not require lawyers, the legal practice that uses cryptography and blockchain technology. It would also change in the way everything is done, and by everything I mean everything, with how we interact with devices. There will be new economic model. We would move on to a secure way of information identification in a connected world, where our privacy where our private information will be much more protected, and the goals of confidentiality, integrity and accessibility is kept much intact. So it's much better model, a much secure cryptographic model, if you look at it from the cybersecurity point of view. So also it is also a decentralization model that is applicable in many sectors. It would change the way everything is done if government adopts the blockchain technologies for governance and for legal practices. Now moving on to the conclusion, so I want to conclude by restating some of the facts about blockchain technologies. So blockchain technology is basically a technology that uses concepts of parallel computing, distributed ledger, transparency, decentralized system that prevents fraud extensively. It is very difficult to hack the transaction mechanism, as many copies of the transaction records are stored in different computers in a larger group of peers, which makes it difficult for the attacker to alter or completely remove the transaction. The block linking mechanism in the blockchain helps to track the breach and can be prevented from being exploited. And with the world moving on to the Internet of Things, where massive data is generated every day, blockchain is already a technology that is proven to be so much more efficient. With its architecture implemented to various multiple dimensions, we're moving into a new world. It will bring various new nuances, and with this application we would encounter more solutions to current problems, and we'll encounter more problems on how to apply them. And also there are many challenges that will then be followed, and I have basically stated all of my references. Thank you so much.